So we'll just wait for, or well, he'll just pop in when we're.
Yeah.
Okay.
I think that'll work. Let's see.
Get over there.
Why is this being weird? Okay. Alright, I just texted him, so hopefully he'll join here in a minute.
Alrighty.
But, what did you guys think of this week? I guess we can kind of start talking about it. I thought it was pretty similar to just the stuff we've been doing.
Yeah, it felt like kind of a review.
Yeah.
Mm-hmm.
Except for I missed a lot of problems due to the simple fact that the standard deviation of the random variable is different.
Yeah.
So I went back and noticed I missed 5 questions because of that.
Oh, wow.
On the homework or on the
On the prep.
Oh, on the prep, yeah.
Yeah, I was like, oh my gosh.
Yeah, the homework isn't too bad. It's just knowing when to do the little extra standard deviation thing.
So when do you do that? Is that just after, is that how you calculate the standard deviation when you're using a size variable? Like a random variable?
So you basically just use the standard deviation divided by the square root of the number of things that you're doing, the sample number, I guess, when you're using a sample. So the homework, I think, asked a question. It said, okay, here's a population. It has a mean of this and a standard deviation of this. Calculate the z-score with this as the x number. So that one you would just use the regular, x minus the mean over the standard deviation.
Mm-hmm.
But then it says, using the same stuff, find what the z-score would be for this specific sample set. So that's when you would have to take into account the root sample, whatever that is.
And you just put that as part of the equation that you're already using?
Yeah, so it's going to give you a little bit of a different z-score.
Okay. I think that's what I was just getting wrong, because I was like, I didn't incorporate that until I realized I was doing it wrong.
Yeah. Okay, he says he's getting on here pretty quick. But yeah, if the quiz today is the homework, then it should be. I did the homework in 10 minutes. It's just calculating. So.
Nice.
Cool. I like that kind of homework.
Yeah.
Me too. But I didn't realize we have a test next week.
I know, I saw that. I was like, what?
Yeah.
I didn't realize we even had tests. I was like, oh, dang.
It's probably just a big quiz.
Yeah.
I hope so.
But I'm wondering if we can take it. Well, we probably can't take it as a group. There's probably a separate assignment for it.
Oh,
Yeah.
that would be nice if we could.
Yeah.
Because we have a great group. I'll just give you guys that much.
We really do. You guys are the best. Okay. Furman. He says my internet is being weird.
That stinks.
Yeah, that does stink.
Okay. Ugh.
I'm gonna go run and grab my calculator.
Go for it. Okay, he says I'm restarting my browser. Having issues.
Oh, goodness.
You're probably getting all these texts too, Miranda. Sorry.
Yeah.
Yeah, I usually just do you two as a group, and then I send one to Kaylee.
Yeah, my phone is like, it's one of the like Walmart phones that you pay as you go kind of, and
Oh, yikes.
it doesn't really do great with stuff, so
Hey, whatever works, you know?
yeah.
Is
Yeah.
it like the Straight Talk wireless, or?
What is it called? I think it's called Total Wireless.
Oh, okay. Yeah, my friend has that, and he says it's definitely cheaper.
Yeah, it's way cheaper. Like I pay $25 a month.
Nice.
Wow, nice.
Yeah, it's way cheaper. But it does have glitches. Like I can't get picture messages and I can't get group messages.
Mm.
Oh, wow.
Okay,
Yeah.
I'm gonna send him another invite. Let's see. How do I do that again? Shoot. Send invite. Okay, sorry. Urban. Alright, let's see. But as soon as he gets on, if you guys don't, if he doesn't have any other questions, then are you guys okay to start the quiz?
Mm-hmm.
I love that we just get it done and it works so nice.
I know.
Hey!
What's up, guys?
Yay!
It worked!
Sorry about that. My internet's been weird lately.
No, you're good. All right. Well, we kind of talked a little bit about the prep work, but did you have any questions?
I did have one. Let's see if I can find it. For it's number 3, letter A. That one, I had a hard time understanding why it's how to figure it out, which percent rule it is.
Oh.
Where it says, what is the probability of a randomly selected individual observation is between 5 and 15, and it's asking for like the 68, 95, 97, 99.7 rule.
Okay, hold on.
I got this one wrong at first too.
So if the mean is 10, that means that's going to be your middle. And so then they just took it from 5 and 15, which if you look at the standard
Oh,
5, so it's
okay.
just 1. Does that make sense?
Yeah.
So then it
Okay.
would be the 68 instead
Oh,
of
yeah.
Okay. Yeah.
like if they had like 17.5 and 2.5, then that would have been 95%
Okay.
because it's just
That
as
Okay, that makes sense.
I think when I got it wrong, I was just overthinking it. And so I like did some weird calculation and then put it into the
applet.
applet, and it gave me this number that was wrong. But I think once you realize that it's just one standard deviation away, then you realize it follows the rule.
Mm-hmm. Yeah, and if you find the z-score should be 1.
Yeah.
And so that's kind of what helped me.
Okay.
But yeah.
Yeah, I just overthought it, I guess. But okay. Other than that, I think I get all of it.
I think so.
Okay, should we start the quiz?
Yeah.
Sure.
Okay. All right, 15 questions.
Okay, I'm a little slow. Just a sec.
Man, I'm like a pro at Google Hangouts now.
I know, it's cool.
You probably are.
Okay, is everybody there?
Yeah.
Sorry. I'm still slow.
No, you're fine.
Okay. Yes.
I'll go ahead and read number 3. So use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and to the left of z negative 1.358. I don't know what I just said. Negative 1.358. Yeah, okay. All right, so...
Right.
So to the right and the left, it said?
Yeah, find the combined area under the standard normal curve. So,
Point
Yes, middle.
175?
0.1745. Yeah.
wait, I thought it was 1.358, and then I got 0.8255.
Do you have the part highlighted that's on the right and on the left but not in the middle?
No, because it says find that's to the right of. Oh, that's left.
To the right of the positive, to the left of the negative.
Yeah,
Yeah.
0.1745.
Yeah.
Or would it just be 0.175?
0.1745. Wait.
Yeah.
Oh, so
Right.
there's 3? Yeah, okay, then it would be 0.175.
Oh, do we need to put the 0 in front too?
I don't think so. You didn't on the homework, so.
Okay.
I mean, if we wanted to be safe, we probably could, but
I can read the next one.
go for it.
Yeah. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean that was observed in the sample. Round your answer to 3 decimal places. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
Yikes. A lot of reading. Find the probability that a random sample pattern will have a weight that is.
Okay, so I think we take 177.6 and subtract it from the mean, and then divide that by the standard deviation over the sample, the root of the sample.
Okay, alright, so the mean is 185, so 185, no, wait, okay, so it'd be 177.6 minus 185, and that would be divided by the standard deviation of 26.7 times
Divided by.
Okay, the square root of the number, which was how many people?
48.
48. Okay, so
Good.
Wait, is it 177.6 minus 185?
Yes.
yeah, and I got negative 1.92.
Yes.
Zero?
I got.
Let me check.
Okay, and we are looking for find the probability. Okay, so then we check on the applet, right?
Uh-huh.
Okay, so we'll have a weight that is extreme or more extreme. So that'd be right and left again.
Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, above or below the mean that was observed in this sample.
So that'd be highlighted blue only on the right and on the left, but not in the middle.
So it says,
I would assume so.
Because you're doing the two opposite extremes.
I think
Yeah.
so. Yeah. So would it be 0.055?
Yeah?
Yeah,
Yeah.
that's what I got.
Yeah.
Okay.
Okay, I can read the next one.
Okay.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, X. The distribution of the sample means. This cannot be determined from the information given. I think it's the second one, the distribution of the sample means, because sample means are generally more normal shaped,
Mhm.
and so if it wasn't a sample mean and it was just the distribution of individual observations, those could have way big outliers,
Mm-hmm.
Yeah.
and it would make the standard deviation bigger.
Yeah, I think you're right.
Mm-hmm.
Okay.
All right.
Brandon, you want to do the next one?
Yep. Which of the following results implies that the spread in X decreases as the sample size increases? Which of the following implies as the sample size increases? That the wait,
Central limit?
I was going to say central limit. Which of the following results implies that the spread in X decreases?
Let's see. The
Spread.
central limit. Let's see. You have observed in the simulations that if the sample size is large, the random variable X will be approximately normally distributed. In other words, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This important result is called the central limit theorem.
Okay, then yeah, that'd be it.
Okay.
I think that one was worded weird.
I think so.
Yeah.
Very confusing.
Okay. So scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and standard deviation of 8.8. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So that would just be 160 minus 150.8.
9.2.
And then divided by the standard deviation.
Mm-hmm.
I got 1.045.
Yep. That's what I got.
Sweet.
1.04.
Yeah.
4.5.
Oh, 4.5? Yeah, that's what I got too.
Okay.
Okay. And then the next one is the same z-score. So we just plug it in the applet. And it's people got above it.
So it's up on the right side.
Yeah. So it'd be 0.148.
Uh-huh.
Whoa, 1.4? Wait, hold on, let me go back.
0.148.
Oh, okay. You already punched it in. I was like, what?
Yeah.
Okay.
Ooh, wait. Okay, yeah. 0.148. Okay. I can read the next one.
Go
Hey.
for it.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores? Round your answer to 3 decimal places. So, we'll take the mean.
Find the mean.
Yeah.
The mean I got was 160.
Yeah, 160.
So, but this one's different because you have to divide it by the root of 5.
Right.
So,
160 minus the other mean?
yeah.
Okay. Minus 150.8 divided by 8.8 divided by
Square root of n.
Okay.
square root of 5.
Right.
Yeah.
Okay, I got 121.68. Does that sound right?
I got 2.338.
Whoa.
Okay.
You said the mean was 160, right?
Well, our x will be 160.
Or the x, yeah.
Yeah.
So, well, that would be 160 minus 150.8 divided by 8.8 divided by...
Did you do 8.8 divided by the root 5 in parentheses?
Yeah. Let me just double check.
What'd you get?
I got 2.338.
Yeah, that's what I got.
I
Okay.
got a different one. Okay, let me do that one more time. Okay, so 160. Sometimes my calculator sticks too, so I don't know.
2.38?
2.338. Yeah.
Or,
I bet that's right
oh,
then.
yeah, good.
Okay, now I got 2.33.
Yay!
2.338.
Yeah.
Right?
Mm-hmm.
3 decimal places.
Okay, this next one confuses me. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So would we just plug that into the 2.338 into the applet?
Yeah, and it would be on the right side. 2.338.
So 0.00, nope, 0.010.
0.010.
Yeah. Oh no, to 4 decimal places. So 0.0097.
Yeah.
Yeah.
Woo!
I think that's a sign that we got it right if it said 4 decimal places. Just
Yeah.
That sounds right.
Okay.
I can read the next one.
Go for it.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random represents the sample mean of the 81 students who are selected?
Should be normal, right?
Sample mean?
Because the
Oh,
size is bigger than 30.
Yeah.
Oh, yeah. So it's normal. Approximately normal.
Okay.
Number 12. What is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? Round your answer. What is the mean of the distribution of the sample means?
Okay, so that one we're solving for x. Wait.
possible.
Yeah. What? No, wait. What is the mean?
It's
Yeah.
3.5.
Wait, how did you do that?
The mean?
Oh, that's right. Okay, so 3.5. Yeah, okay. Sorry. I was overthinking that one a lot. Gee. Okay.
Wait, the answer is just 3.5?
Yeah, because it should be the same.
Oh.
I know, I overthought that one so much.
Yeah.
I
Like,
thought
don't
we
we
were
do
going to use that weird equation where we had to solve for x and stuff.
Yeah,
That's what I was
like, oh, they
thinking.
don't give us a z-score.
Yeah.
Yeah.
Okay. What is the standard deviation of the sampling distribution of the random variable x, the mean of 81 students who are selected? So, standard deviation, if it's 3.5, it should be 0.7,
0.7.
right?
Yeah.
Yeah, I would say so too. But then why would it ask us to round our answer to 3 decimal places? Just put 0.700, or we have to do the standard deviation divided by the sample size.
Oh, I think it is the sample size because it says of the sampling distribution. So it would be 0.7 divided by square root of
Square root
81.
of 81.
Possibly?
Oh. What is it standard?
Because that one pops out as 81, so just do 9. 0.078.
Yeah. So it's basically, oh, it's a little different, yeah.
So, wait, 0.07? So did you get 0.07?
Yeah, so this is what it says in the book. I'm just going to read this really quick. The collection of all possible sample means x is also a population. The mean of the distribution of the sample mean is the mean, which we got. And then the standard deviation of the distribution of the sample means is standard deviation divided by root.
Okay.
n. So we're right.
Oh.
Yeah,
Okay.
that was right.
Okay, so 0.078.
Yeah.
Okay. What is the probability that the mean GPA for 81 students will be less than 3.3? So this one we have to do the equation.
Okay.
Root 1.
Standard deviation.
I got negative 2.57 as the z-score.
Negative 2.57?
Yep.
That's what I got.
And then it's asking for less than, right? So just be to the left of the negative,
Yeah.
which is 0.0051. So 0.005.
Okay.
0.00. So you guys said?
0.005.
Yeah.
Okay. That's what I got too.
Yep.
Oh, and
Will
the
be
next one.
greater. So it's just like 1 minus that.
So 0.9949
Yep.
or 0.995.
Cool.
Nice.
Oh, we missed one. Ah, dang it.
Oh man.
What did we put down for 5 again? Was it the distribution of the sample means x?
Yeah.
Okay.
Darn it. The law of large numbers.
Darn, that one is like a mystery.
Yeah.
That one is so confusing.
And no one, we don't really talk about it.
No. Oh well, I'll take a 94. Works for
Yeah.
me.
Still an A.
The law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean.
Huh.
That still doesn't clear it up for me.
The way that question is worded kind of doesn't make a whole
I
lot
know.
of sense.
Sounds all backward.
Yeah, that's weird.
Oh well.
Well, we still did all right. Good job, team.
Nice. Yay!
Have a good weekend, everyone. I'll go ahead and post the video.
Okay,
Sounds
thank you. Thanks
Awesome.
for getting it worked out and everything.
Yeah, no
Thank
problem. See you
you.
guys all on Monday.
All right.
All right, see
Bye.
you guys.
Bye.
Bye.